On this DeBacco University video, I'm going to cover the three main types of chemical bonds that you see listed here, as well as some subsets below, particularly for covalent. All right, so first off, we should probably define what a bond is. And a chemical bond is essentially the force that holds atoms together to form molecules in compounds. Most chemical reactions you see, such as rusting iron or baking bread, digesting food, are just atoms rearranging their bonds, reforming different bonds to form different end chemical structures, because as you may remember, matter cannot be created nor destroyed. So when we get to specific types of bonds, ionic bond is one example. One atom donates an electron to another, creating a positive and a negative ion that attracts one another. The atom that loses the electron becomes a cation or positive, and the atom that gains electrons becomes an anion or negative, because as a reminder, electrons are a negative charge. If you get more electrons, your charge is going to go down. This is typically between a metal and a non-metal, and we see that with sodium chloride, NaCl, which is table salt that you may be more familiar with. So here we see a transfer of an electron forming this positive and negative charge, and those opposites attracting one another is forming this ionic bond. Now the covalent bonds, atoms share electrons to reach a stable electron configuration, and this is typically between nonmetals, and we see this with water, H2O, as well as carbon dioxide. We have atoms here that have unpaired valence electrons. They share those. Because they're sharing those bonds, each is able to maintain that stable octet. However, as I mentioned in the introduction, covalent bonds have a couple subsets with them. So with our covalent bonds, we can have single, double, or triple covalent bonds. This results in molecules are often gases and liquids. The single bond is one pair of electrons are shared. Double bond, two pairs are shared. And as you can imagine, three pairs are shared are called a triple bond. You can see that represented here. Again, we usually just draw the lines to make it easy. Every line means that there's basically two electrons there being shared in that bond. Here's a single, a double, and then a triple bond. However, within our types of covalent bonds, we also have what's called polar and nonpolar covalent bonds. Polar covalent bonds, our electrons are shared unequally due to differences in electronegativity, creating a partial charge. We see that particularly with water, where oxygen is more electronegative, pulling the electrons closer to it. It's a bigger molecule, creating a partial negative charge on the oxygen, and as a result, a partial positive charge on the hydrogen. And we can see that right here. We're pulling those electrons in. We're getting that bigger molecule, again, cramming those electrons closer to it, creating more of a negative charge. As a result, the electrons a little bit more stolen from it, unequal sharing, we have a slight positive there. In contrast, we have what's called nonpolar covalent, which is probably the easiest to think about. And these are electrons are shared equally because the atoms have similar electronegativities. We see that with our diatomic elements here with chloride. The electronegativity difference is essentially zero, and that shows a symmetrical or even sharing of those electrons. With those nonpolar covalent bonds, again, being shared equally between atoms, there's no dipole, there's no partial charges. The atoms involved have similar or identical electronegativities, which is a tendency to attract electrons, with the molecule often being a symmetrical shape because of that evenness. These molecules tend to have a low boiling and melting points and are not soluble in water. They can dissolve in other nonpolar substances such as oils. Hydrogen molecule, methane, oxygen molecule would all fit in that category, as well as nitrogen, as we see here. Now those polar covalent bonds, diving these into a little bit more detail, these are when our electrons are shared unequally between atoms, creating those partial positive and negative charges. One atom has a greater electronegativity, and that's going to pull those electrons closer, creating a molecule that has an asymmetrical shape. These molecules have moderate boiling and melting points and exhibit interesting behavior like hydrogen bonding and are usually soluble in water. Water would be a prime example of our polar covalent bond, as well as ammonia and hydrogen fluoride. You can see them represented here as well as here. This big oxygen, again, pulling those electrons closer. That's why you see that partial negative, and then those resulting two partial positives at the end of those hydrogens. And then lastly, we've got a metallic bond, which is metal ions share a sea of delocalized electrons that flow freely. They're basically able to move throughout there. The strength of the bond depends on the number of delocalized electrons and the charge of the metal ions. Copper, Cu, used in electrical wiring due to its excellent electroconductivity. Iron has strong metallic bonding, contributes to its use in construction. So we could see how knowing the certain bonds of certain elements can allow us to determine the properties and determine what might be a good fit when it comes to designing certain projects or needing to meet certain requirements.